Hi, this is Olivier Gonzalez. I am the engineering manager for composition analysis group in Secret Stage. And today we'll talk about continuous vulnerability scans. This is a very important feature for both continuous scanning and dependency scanning feature categories. And it's also going beyond that with some potential unlock for further improvement in the dependency management feature category and some other aspect in the software supply chain security. So we are very eager to move forward on that. And through that presentation, or at least the series of short videos, I will explain how we are doing things today, how continuous vulnerability scans would compare to that, what will be our intent in the implementation, because there are some very challenging aspects technically. So we'll have some discussion around that, and also some expectations in terms of planning, when we expect to deliver that, or at least hope to deliver that. And hopefully that will address all of your questions. If you had any other follow-up questions after this presentation, feel free to reach out to us. You can contact us directly by commenting in the epics, or you can reach out on the Slack channel if you have access to this. So as a first step, this is a little glossary about a few words that you might, acronyms that you might encounter a lot there. Continuous scanning, dependency scanning, and continuous vulnerability scans. Those are such long words that it's rather faster to use those acronyms. Also, this is a reference to the EPIC if you want to have a further look and comment there. So let's talk about how things are working today. Basically, continuous scanning and dependency scanning work in a very similar fashion by taking on one side the list of components on your project, either the repository or the Docker image for continuous scanning, and on the other end, having a database of known vulnerabilities for such components. The scan itself can be simplified roughly into a matching logic that takes two data sets and try to figure out the join between the two. So usually an advisory would get the details about a given package, and it will list the affected versions, or at least a range of impacted versions for that package. On the other end, the SBOM or the dependency list would tell us which version of your component, of the component you are using in your project. And for each of those, we would verify if the specific version is within the range or the list of affected versions for each advisories. Once we've done that, for all the advisories, we move on to the next component, and so on and so on. Once we have done, we keep the results in a report that gets uploaded as a security report artifact, ingested in the database, and feed into our vulnerability management system. This approach currently relies heavily on the CI job to do that matching logic and report generation. This means it's really tied to having a pipeline running. And as we've seen, there could be other events outside of the pipeline lifecycle that can generate new vulnerabilities for your project. A good example is a project that is rather stale or doesn't have a lot of changes. There won't be no new pipeline triggered on that, but there could be new advisories disclosed for existing component in your project. And you won't know about that until you rerun a pipeline. The best workaround we have so far is to run a scheduled pipeline regularly to trigger new scans and check that you don't have any vulnerabilities that are new for your project. The continuous scans is trying to alleviate that by going through a more stateful approach and a more event-based approach. So we're not really continuously scanning, but we're more focusing on what are the relevant events that needs to trigger a scan. And this is, again, any change in your SBOM, which will still rely on having a pipeline being triggered. And then on the other hand, when our database is updated, because there is a new advisory or because an advisory is being used, since we know about your SBOM, we will be able to let you know that your existing components are impacted by that update. That is a very neat improvement for us. And again, since we're moving to a more stateful approach, it will unlock a lot of other interesting features that can be built upon that database information. So what needs to be done to achieve that? Because that's exciting, but there is a lot of work. So here you can see a simple diagram highlighting the big part that needs to be achieved. And both for dependency scanning and continuous scanning, we will try to reuse and mutualize as much as possible between the two, but this also means there is some sequential aspect into the development of those parts. We also have a color code here, a color code here to highlight our level of confidence in addressing those tasks. That is mainly defined by the level of uncertainty, complexity, the risk, or the velocity associated with all of those parts. So let's have a look, and maybe that will also answer a lot of questions around how we can achieve that. So as I mentioned earlier, we need two things, the SBOMs and the advisories. Storing the SBOM in the database is already fairly done. The working group that worked previously on that part has done 99% of the job, I'd say. There are a few adjustments that needs to be done for fulfilling our needs, but that's already pretty done. And this is relatively straightforward. This is something we know well. The generation of the SBOM is already something that is done in the CI job today. So there is no much unknown or things that left to be done there. The advisories is something that we also manage ourselves for dependency scanning. So we have a fair amount of knowledge around that. It's self-contained in a Git repository. So ingesting that information should not be a big problem. Once we have those two things together, we can start working on the components and advisory matching logic, which is what I mentioned earlier. There is an additional level of uncertainty here because we are not sure yet where we want to implement that. We already are doing that work in the dependency scanning CI job. So it's just a matter of moving that logic somewhere else. And this is a proof of concept that would tell us whether we go with moving that into the REST application, or we rather move that into the brand new infrastructure that we develop for the new license scanner. This will be further explained in the details, but for this overview, I will just stay there. Once we've achieved that, there is a very huge part that remains, which is what I call the CVS logic, which is adapting the existing code and all the logic that we've developed for the past 5 years to move away from that concept of I am tied to a CI pipeline to something else. And that means all the code base that we've built along those years has to be updated. And this is a fairly big amount of work. Not a very high complexity, but it's hard to predict the amount of work there because this code is spread into the Rails backend. It is also mutualized between several other security reports. And this means we will have to extract the bits that are specific to dependency scanning and container scanning into another abstraction level to achieve that, because we also want to maintain backward compatibility with the current approach for the third-party integrators. So this is a very uncertain and highly risk, with a high risk part to achieve. Once everything is done, we will have our MVC. This is also a critical point to understand here. Between the current approach and what continuous scans will deliver, there won't be a lot of visual changes for the customer, because in the end, it's not about where we are putting that information, but how we are achieving that scan and where we are achieving that scan and when particularly. But in the end, both approach will feed the existing vulnerability management system. So whether we're running with the old approach or the new one, you will see the results in the vulnerability dashboard, for instance. So it's very difficult for us to have a user visible change at any time during the development process. It's very difficult to just demonstrate one piece from a user side. This is a bit of a concern because this doesn't really represent our iteration value. We'll try to challenge that and come up with maybe a more iterative approach. But again, until the CVS logic has been implemented, it's very difficult to show the benefit of that new approach. We'll definitely will be able to demonstrate progress through some more internal demonstration, like making sure that we're able to ingest the database of advisories, or we have the SBOM available, something like that, but that's pretty minimal. And then once this is done for dependency scanning, we have to repeat the same thing for container scanning. The good thing is that a lot of what will be done for dependency scanning will influence or rather be reused totally or partially for container scanning. So that's why, for instance, you may see that for the CVS logic part, we have a higher level of confidence because this could be basically a rinse and repeat for container scanning. Getting back to the beginning for container scanning, the SBOM part is relatively straightforward. This is something that we already know how to achieve for I'd say most of that. So we're mostly very confident about achieving that. On the other end, the advisories for continuous scanning is something that is much more complex. The data is spread amongst multiple databases, and this is currently mainly handled by our open source components. So we need to have a better grasp at how this data is built, what it contains, because we will have to make sure we can manage and handle that data ourselves and feed it into the matching logic. And again, there might be a little level of uncertainty here because matching logic for open operating system packages might be slightly different than for application packages. But again, once we will have achieved that for dependency scanning, all the architecture, the framework to do that will be already in place. So it would just be a matter of having the specific logic for continuous scanning packages to be applied. Again, there is not a lot of opportunity to demonstrate an iteration there. And this is also highly dependent on the progress made on dependency scanning. In the planning part, I will go further into the details about how we plan to address those different parts and when we expect to start and deliver them. But this gives a good overview about the dependency between all of those tasks. So thank you for watching. There will be other videos coming for the details about what needs to be done and some others about the planning. So see you there, and thank you for watching.